Alrighty, so we are going to go through questions 29 all the way through 43. Some classes did get to answering them and some classes don't. So feel free to skip through this video to get the answers of whichever questions we still need to go through. And that way you can figure out how you did on those questions. Again, make sure to look at this and hear these explanations after you've attempted this, after you've looked at your notes. Don't just look at this to get the answers, because that's not the point of these questions. All right, question 29 was saying that triangle FGH was translated. Translated automatically tells me that I'm moving. So this means either up, down, or left, right. It says 7 units to the right, and it says 3 units down. To create the new triangle, I know this one is the new one because it has the prime symbols, right? A rule that describes that transformation. So I know whenever I'm moving to the right, that means I'm moving on the x-axis. Remember x, and then you squish it, creates the x-axis. Then when I think about where my positive numbers are, it would be to the right. So therefore, it's going to be x plus however many I'm moving. In this case, 7. Then it said down. So now I know down is on my y-axis. Therefore, and down would be negative numbers. Therefore, I'm going to have y minus, in this case, 3, because that's how many units I'm going down. Therefore, my rule would be x plus 7 and y minus 3. All right, and here we have a quadrilateral that undergoes a single transformation. So that means that it does just this, or just this, or just this, or just this. So you're doing them one by one. For each transformation listed in the table, indicate which of the features remain the same. So we're trying to figure out if the orientation of the vertices stayed the same, and then if the side length stayed the same. Now, orientation of vertices just means that if I have a quadrilateral, so let's say a piece of paper, like this packet that you're looking at, if I have a staple in this top left corner, if I then move this piece of paper to the left, is the staple going to remain in this top left corner? If so, then your orientation of the vertices stayed the same. If I take the same piece of paper and I rotate it, so now it is laying like this, it is no longer in that same corner. So now the orientation of the vertice has changed. So over here, it was in my top left corner, and now it is on my bottom left corner. So therefore, it did not stay the same. So that's what we're looking at as we're going through these. And then we're also looking at if the side length stayed the same. So over here, did this side measurement change at all? No, it did not. Over here, did the side measurement change at all? No, it did not. All right, so let's go through these. The first one, that algebraic rule tells me that it is being dilated. I know that because I see multiplication, and the only one where it multiplies is dilation. Because the number is more than 1, I know that it's dilated to make it a bigger shape. So therefore, my piece of paper, if I think about that, it's going to go from a small piece of paper to a big piece of paper. So think about that staple, though. Would it stay in the top left corner? Yes, it would. Would the side measurements change? They would. All right, so because over here, it's going to be small, but then I'm making it bigger, so it's not going to stay the same. A reflection across the y-axis. That means if I had this piece of paper over here, then I have my x and y axis is going to reflect over this, meaning that afterwards, it'd be like a mirror, and the staple would be on the top right corner. So therefore, the orientation does not stay the same. The side measurements, how long this is, does stay the same. This next one is a transformation, or a translation rather, because I'm adding and subtracting. In this case, this means I'm going 5 to the left because I'm subtracting from my x-axis, and I'm going 8 up because I'm adding to my y-axis. So if this piece of paper moved 5 to the left and then 8 up, it would be over here. Now, where the staple is did not change, so that stays the same, and the side measurements will also stay the same. Then finally, if that quadrilateral is rotated 180 degrees, That means that my original piece of paper is going to turn 90 degrees and then 180 degrees. So the orientation of that staple changed because it's no longer in my top left corner. It's now in my bottom right corner, but the side measurements did always stay the same. So that last one needs a check on the side measurements. All right, question 31. It says a triangular prism and its dimensions are shown in the diagram. Because it is a triangular prism, I automatically know that my bases are the triangles. So I'm going to go ahead and highlight those to remind myself. Then complete each statement. It wants you to figure out the lateral surface area as well as the total surface area. Both of these formulas can be found on your bestie. Lateral surface area is pH. Total is pH plus 2b. Remember, we changed those capital B's to the letter A's because we want to find the area of the base. So first thing we need is the perimeter of the base. So that's the perimeter of the highlighted part. So the outside of this triangle, I'm going to add up all the measurements. So that would be 10 plus 10 plus 12 gives you 32. I know that this side is equal to this side because of the little dashes, but also this back one is 10, which means this front one is also 10. Then I'm multiplying that by the height of my prism. That means from one triangle all the way to the other triangle. Therefore, this 15.5. And that would get me an answer of 496 square inches. It already says square inches here, so I would just need to drag in that number. For total surface area, I now also need to find the area of the base. Because my base is a triangle, I need to find the area of a triangle. So this is on your bestie as well. It is 1/2 base times height. So now again, we're just focusing on the triangle. Everything else about this picture is no longer relevant to me. I just want to know the area of that triangle. So I need 1/2 of the base of the triangle, or the bottom, in this case 12, times the height of the triangle, which would mean all the way to the top. In this case, it was 8. It was back here, so that means this front triangle is also 8 as the height. That would give you an area of 48. And now we're just going to put everything together back in the formula. So the perimeter was 32. The height of the prism was 15.5. It says plus 2, so I need plus 2. Times the area, which was 48. When you plug all of that into your calculator, it'll give you an answer of 592. And that's how many square inches the total surface area of this triangular prism is. All right, next up we have Annika that has an outdoor storage bin shaped like a rectangular prism. So I know my bases this time are rectangles that holds her pool toys and inflatables. The base of the storage bin measures 5.5 feet by 3 feet, and we know the total surface area is 75.5 square feet. What is the height of the storage bin? So total surface area tells me that I will be using this formula. Then I already know the base. So if you were to draw a picture of this, you just draw a rectangle with a similar sized rectangle within it, and then connect your corners. If you are a visual person and you need that, you can go ahead and draw that. What we know is that the base, or the bottom, and the top measure 5.5 and 3. So that allows me to figure out the perimeter as well as the area, and I am just looking for the height. So we're gonna go ahead and figure out the perimeter, which I know is 5.5 plus 5.5 plus 3 plus 3, and that would give you 17. I can also figure out the area, 5.5 times 3, which would give you 16.5. So filling in everything I know in my formula, I know that the perimeter is 17. I do not know the height, plus 2 times the 16.5. Now I know that the total surface area has to equal to 75.5. So So the easiest thing that you can do for yourself, since you do not have answer choices and it has to be one of 4, is just by starting to guess with a random number. Let's say you guess that the height is 5. You would plug all of that into your calculator, and you would get an answer of 118. Since 118 is more than the actual answer you want, you know that 5 is too big of a number and therefore need to try a smaller number such as 3 or 2 or something else. Eventually, you're going to figure out that the answer to get to 75.5 is a height of 2.5 feet. So therefore, 2.5 would be your answer because it gives you the calculation of 75.5 as a final answer. Therefore, 2.5 would be your height and your final answer for this question. This one says that a table shows the dimensions of 4 cylinders, which 2 cylinders have the same lateral surface area. So finding my lateral surface area formula for a cylinder on my bestie is 2 pi radius times height. What I'm given in the table is radius already and height already. So I do not need to do anything to these numbers because that's exactly what I want. I want the radius and I need the height. So what you're going to do in your calculator is 2 pi times 6 times 5, 2 pi times 4 times 7, 2 pi times 2.5 times 11, and 2 pi times 3.5 times 8. You'll notice that the only 2 that end up giving you the exact same answers are S and U, and I believe that those 2 answers are 175 point something. All right, question 34, we have a cone, and the cone is given to us in this picture.